Doctor, did you record this?
Yes, I did. I did started now. We will divide. We will make today two recordings. One for the first part and one for the second part. So you got the idea, Shabab. This is the linearization. For the differentials, it is just coming from the idea that you have f prime of x. You know that it can be written in the Leibniz notation like dy over dx. So now here, this is a notation, Shabab. D over dx, it means prime. So if here you put y, here you put y. It is the same idea. But here you can deal with them. If you remember, we have defined the derivative in chapter 2, if you remember, to be the limit of delta y over delta x when delta x goes to 0. So now you can, of course, write this approximately like this. So you can say that dy over dx is approximately delta y over delta x, because this is a kind of limit. Now what we will do, we will deal with dx, which is approximately dx now, it is approximately delta x. And dy, it is approximately delta y. What is delta y? This is delta y. You can see, just remember the triangle here, how to calculate it. This is delta x. So because of that, you can think about it like independent variable. Look, dx is independent variable. So you can divide now or cross multiply both sides by to have this. Now this is delta y. This is what I said. It is approximately. This is what is called the relative error. So we have two differentials, dy and dx. dy depends on the derivative and on dx, but dx, it is independent. The relative error, ya shabab, it is just dy over d, the difference, or the delta y over dy over y. The percentage, it is just this one, but multiply by 100%. We will have some exercises about this, and you already had in the lectures. So this is an example about, or an exercise about this section. So find the differential dy. This is y. So what will be the differentials dy, ya shabab? dy will be the derivative of x dx. This is what is the definition of the differential dy. So what is it? It is equals to f prime. What is f prime of this function? It is 0 plus 2x over square root over 2. What I'm doing, ya shabab, is I'm differentiating the square root by using the chain rule, multiplied by 0 plus 2x. Instead of that, we usually write this here. So it will be like here, 2x, and 2 will be cancelled with 2. So this is what we have. Don't forget dx. Now this is dy. This is a. This is part A. Just we differentiate. Now evaluate dy for the given values of x and dx. Now evaluate it at these values. So easy. It is a kind of substitution. So what is x? X is 1 over square root of 3 plus 1 squared is 1. What is or dx? Dx is negative 0.1. Simplify. This is what? Square root of 4 is 2. And this is negative 1 over 10. Is that right? So what is this? This is negative, I think I forgot x here. It is x 4, 2, negative. It is okay. So it is negative 1 over what?
Over 20.
Over 20, which is negative 0.05. The dy is this now, when you have specific values. So I think this is enough. This exercise is the one that we will solve together. The others, we will solve them, inshallah, in groups. Let's go now to 3.11. 3.11, it is the best end for chapter 3. Very interesting and very easy section. 3.11 is about hyperbolic functions, or hyperbolic trigonometric function, in fact, some they call them. So it is about hyperbolic sine, and the functions obtained from them. So what is the sine hyperbolic, or the hyperbolic sine, or sine, shine, you can read it as you want. The sine hyperbolic, it is just the difference between these two exponential functions. So it is the natural exponential e to the power x minus e to the power negative x over 2. The cosine is the same, but with a plus. Now, if you divide sine hyperbolic by cosine hyperbolic, you will have tan hyperbolic. Similarly, you will have cosecant. It is the reciprocal of sine hyperbolic, and the secant is the reciprocal of cosine, and cotangent hyperbolic, it is the reciprocal of the tan hyperbolic. You see that why they call them sine and cosine, and you should know that, Shabab, because they behave similarly. The relationship between them are similar to the relationship between the trigonometric functions. Also, the identities, their identities are the same. And why they call them hyperbolic? They call them hyperbolic because of this relation. I will show you next in the next slide. These are the graphs. This is the graph of sine hyperbolic. This is of cosine hyperbolic. This is of tan hyperbolic. So it will be easy for you to recall what are the domain and the range of these functions. So it is easy. The domain for all of them is all the real numbers. For the range, for sine hyperbolic, it is R. For the range, for cosine, it is from 1 close to infinity. For tan, it is from -1 to 1. Remember that tan hyperbolic, it has two horizontal asymptotes, 1 and -1. Now the hyperbolic identities, this is why they relate them to sine and cosine, Shabab. They have noticed that sine hyperbolic is odd, and also cosine hyperbolic is even, similarly like sine and cosine. But look at this identity. It is not the same as that we have in the trigonometric functions, so be careful. In the case of the usual squared x minus circular functions, because if this is theta, let's say this is t, this is t, so this will be like x squared plus y squared equals to 1. This is equation of what, ya Shabab? This is an equation of a circle. So they call them circular functions or trigonometric functions, because this is also by Pythagorean theorem, it is the same as the trigonometric. So they call them trigonometric or circular because of this. Now these functions, what do you want, ya Shabab? In the chat, is there any problem? Is the sound is okay, or there is a problem? Let me check the speakers of my computer. I wish it's okay now.
I think it's because of the connection, Doctor.
Maybe there is a problem in the internet connection. I don't know. Now,
Fine,
Shabab,
now.
what about now? Can you hear me?
Yeah, it's good now.
Yes, it's good.
Okay, now, Shabab, if this is theta, let's make a theta or t or whatever. Just now, if you put this equals to x, you will have x squared plus y squared equals to 1, not plus, minus. This is minus. So this is equation of what, Shabab?
Similar to the hyperbola.
It is hyperbola. Yes, it is an equation of hyperbola. So the name is coming from here. Why they call them hyperbolic. Okay. Now you can see also the identities are similar. You need to prove them, طبعا. All of them, Shabab. Now update your table of derivatives. Add, ya Shabab, this sine hyperbolic x, its derivative is cosine hyperbolic. Look at the difference here. The derivative of cosine hyperbolic, it is not negative sign like what we have in the trigonometric. No, it is sine. The derivative of tan hyperbolic, it is secant. Now for the remaining derivatives, all of them are negative. So this will be easier for you to recall. These derivatives are the same also, but all of them are negative. Of cosecant, secant, and cotangent. So let's solve these exercises. Prove this identity. So easy. How to prove this, ya Shabab? What you need to do is to start with the left hand right or the right hand side. Start with the left hand side or the right hand side. It is up to you. Start with the left hand side, which is sine hyperbolic negative x. It is equals to what? Do you remember what is sine? It is e to the power, the angle here. It is e to the power negative x minus e to the power negative x. It will be plus x. Are you with me, ya Shabab? This is the definition of the sine function, the sine hyperbolic. This equals to e to the power negative x minus e to the power x over 2. Now, if you notice, what is sine hyperbolic x? Sine hyperbolic x, it is e to the power x negative e to the power negative x over 2. So how this is related to this?
It's multiplied by -1.
if you take negative as a common factor, you will have e to the power x minus e to the power negative x over 2. Just take negative as a common factor. So this is negative sine hyperbolic x. You can do the same, of course, for cosine hyperbolic. So now we proved that the right-hand side, the left-hand side equals to the right-hand side. Similarly here, if you start with the left-hand side, which is cosine hyperbolic x, which is e to the power x plus e to the power negative x over 2, plus this sine hyperbolic, it is e to the power x minus e to the power negative x over 2. This equals to what? You have the same denominator here, 2. Now e to the power x plus e to the power x, it will be 2 e to the power x. Now e to the power negative x minus e to the power negative, it will be 0. So what we have at the end, 2 over 2 is 1, and we have e to the power x, which is the right-hand side. What we learned, ya shabab, from these two identities, that if you want to prove or if you want to deal with any hyperbolic function, write it as the original definition. It will be very easy for you. The derivatives, of course, the derivatives, you need to apply the chain rule. Of course, they will not ask you what is the derivative of tan hyperbolic x. They will give you some functions inside. So here, what is the derivative of this function? What is the derivative of the inner function? The derivative of the inner function, it is 1 over 2 square root of x, am I right? Times the derivative of tan is what? Secant hyperbolic square root of x. Done. This is the answer. If cosine or cosine hyperbolic x is 5 over 3 and the x is positive, then find the values of the other hyperbolic function at x. This will remind you about 002. Yeah. Now, how to find that? How to do that? What is the easier one that we can obtain from this? Secant. Am I right? What is secant? Secant hyperbolic. 3 over 5. The reciprocal of cosine.
Yes.
So it is the easier one. Now, how to obtain a shabab sine?
The identities.
Identity. What is the identity? It says that cosine squared x minus sine squared hyperbolic x equals to 1. Now, what is this? This is 25 over 9 minus sine squared x equals to 1. Now, move this to the other side. So it will, or move sine. Sine, it will be easier. Move sine to the other side. So this means that sine hyperbolic x will be equals to, we said that this will be
25 over 9.
Over 9. This will be minus 1. What is it?
16 over 9.
16 over 9. So this means, this is the first one that we obtained. This means that the sine hyperbolic x is equals to what?
4 over 3.
4 over 3. Now you can have all the others easily. Now you can have secant, cosecant. Cosecant hyperbolic, 3 over 4. The tan will be sine hyperbolic over cosine hyperbolic. Halas, you can, if you have sine and cosine hyperbolic functions, you can have the others easily. Halas, if you have these, you can just take the reciprocal here, divide sine by cosine, and so on. Now I think we will go to groups. So now I want you, Shabab, to take a photo, please. Take a photo of this slide to know your group. Now I will divide you into 5 groups. So each group will solve the exercise related or corresponding to the number of the group. So if you are group number 1, you will solve question related to group number 1, and so on. So please take a photo of this slide and solve the problem corresponding to your group. So what I'm going to do, ya shabab, now, I will send you to the breakout rooms. So now you will be in a smaller room with only like you are 38, like 7 from 6 to 8 students, 6 or 7 or 8 students. So automatically you will be divided. Let me create rooms. So no, I need the options. Let me start again. Breakout rooms, how many rooms? let me divide you into 5 rooms. So, okay, like I said, 6 or 7 or 8 maximum. Okay, now you will be a shabab now sent to another room. So after like 5 minutes, I will give you 5 minutes. It's okay, at most 5 minutes, and I will send you ask you back to come back to the general room. Okay, are you ready now, ya shabab, to move? I want you to move to the room and discuss there the problem corresponding to your group room, to the number of your room. And one of you, ya shabab, choose one to be a leader, and that one he will discuss with us in general in the general room the idea of this exercise and how to solve it. So I want every group to choose a leader or a spoken man to talk to us after coming back to the common room. So I'm gonna open now all the rooms, and you will be now sent to the room. Okay, so you can, ya shabab, now start now join the request. You can see now a request to go to the smaller room or to the group, and please join that group. And of course you have to leave from this meeting to the shorter or the smaller meeting in the breakout rooms. I can see, ya shabab, that some of you, they still here. I can see that you are still there, ya shabab. Ahmed al-Dawood, Salih al-Sagadi, you didn't join. Join, ya shabab. Ahmed al-Idris, Ahmed Idris. Ya Ahmed, Ahmed Idris, Ahmed Idris, you didn't join.